Hey everyone, Mr. Voikin here. This is Unit 4.3.1 using formula, but let's get started with some review of 4.2.2. On the teacher's side, we have an inequality and it says to solve for the unknown, x in this case. This is a single step equation, very simple. We're going to add 5 in order to eliminate that -5 on the left hand side and isolate that x. Whatever I do to the left, I got to do to the right. So I end up with x is greater than or equal to -4. Okay, that was really easy. So let's move on to something a little bit more complex. I have a two-step equation. So in this case, we're going to add 7 to both sides. And I have 4x does not equal 12. To isolate the variable, I will divide by 4 on both sides, and I get x does not equal 3. So what that means is x can be any value except for 3. If it's 3, it's going to make the statement up above false. So let's take a look at that. The original question says 4 times x minus 7 cannot equal 5. Okay, so that means I do not want, in this case, what's on the left to equal what's on the right. I want them to be different. However, if I put a 3 in here, you'll notice that I'll have a 12 minus 7, and 12 minus 7 is 5. And again, we want a does not equals here, and in this case, 5 equals 5, so I know that this answer right here is correct. Okay, the third question in the review, and the last one, says to solve this and then graph. Now remember from the last lesson, as soon as you see a negative coefficient, you know that you are going to be flipping this sign in your final answer. So let's get into it. We're going to subtract 40 from both sides. Now I have -7x is greater than -42. I'm going to divide by a -7 on both sides, and I get x's, flip the sign, less than 6. Okay, and to graph that out, because it's less than and not equal to, it's going to be an open circle, and less than tells us to go to the left. And there we go. So now it's time for you to try the student questions on the right. Pause the video and come back to check your work. Okay, let's take a look at the answers. In number 1, you should have t is less than 2. In question number 2, you should have t is less than or equal to 7. And notice that because the -3 coefficient, we had to flip that sign in our final answer. And the last one also had a negative coefficient, so you can see that we have flipped the sign in our final answer, giving us t is greater than or equal to -4, and that is what the graph should look like. Okay, let's move on to 4.3.1, and it says we're going to be using some formulas. So this is a very standard formula for the perimeter of a rectangle. It is going to be P, which is the perimeter, is equal to 2 times L, which we'll call the length, and plus 2 times the width. So the first question tells us find the perimeter. So that means the perimeter is the unknown one. That is what we're trying to figure out. In this case, we would have to be given the values of L and W because we can only have one unknown in order for us to solve. So let's take a look at it. We're going to be solving for P, and that's going to equal 2 times L plus 2 times W. And remember, I said the best thing to do, put those brackets there in place of the variables, and then you want to substitute the values given into those brackets. So what do we have? The first one is L, and it says the length is 12, so we'll put a 12 inside here. Come on, my pencil is not working for some reason. Here we go, 12, there we go. And the width is 8. So now it's a very simple calculation. It's just P equals 24 plus 16, and P equals 40. Now, the one thing you don't want to forget here is that perimeter is a distance. Distance has units, and in this case, it is centimeters. Okay, now using that same formula, the second question says we're given the perimeter. So the perimeter is 30, and it says the width is 4, and in this case the units are millimeters. And what do they want us to do? Find the length. So in this case the length is the unknown. So the difference here is that the first one is quite simple because the variable we're trying to solve for is already on its own on the left. But in this case we have our formula, which is going to be P, and it tells us that P is 30. And 30 equals 2 times the L. Okay, and what is the L? Well, we don't know the L, and we're going to add to that 2 times the width, which in this case is 4. So if we simplify things, we've got 30 equals 2 times L plus 8. And now I just need to use some two-step algebra to solve for L. We will subtract 8 from both sides, giving us 2L equals 22. We're going to divide both sides by 2, and we're going to get L equals 11. And again, that is going to be millimeters. So our answer is L equals 11 millimeters. Okay, now you could verify that just by sort of taking a look at a rectangle and saying, well, if the width is 4 and 4 and the length is 11 and 11, if I add all those together, do I get 30? And the answer is yes, I do. Okay, so let's move down to the last one, and it's basically the same as the other one, except this time they're giving us a perimeter, a different perimeter, and the units are meters. They're giving us a length, and the units on that is also meters, meters, and we need to find the width. So let's go back into it. The perimeter is 110. That's going to equal 2 times the length, which is 40, plus 2 times the width. W is our unknown, and we need to solve for that. So we get 110 equals 80 plus 2W, subtract 80 from both sides, and we get 30 equals 2W, divide by 2 on both sides, and we get W equals 15, and the units are meters. Okay, now that that is done, seems fairly straightforward. It's your turn to do the student work on the right hand side. So pause the video and come back to check your work. Okay, so let's take a look at the answers. For the first part, you should get the perimeter P equals 41 meters. Don't forget those units. And after some calculations using some decimal values, for part 2, we get that the L, the length, is equal to 14.5 meters. And finally, in the last one, we get that the width is equal to 10.4 meters. All right, we're going to work on these last 5 problems or questions, and then have you do some on the right, and then you're going to be ready to answer the textbook questions on this type of work. So what are we doing? We are rearranging the formula to solve for A. So right now, what that means is that X is isolated. So this formula that we have here, which has 2 variables, X and A, it is arranged in a way that we're going to plug in a value of A to solve for X. So if we were going to be given a whole bunch of values of x and we want to calculate a, it's best that we have the a all alone. So basically we just want to get rid of that 2 so that we can isolate this a. Now I can rearrange the formula as we sort of like having it reading left to right. This is the same as a plus 2 is equal to x. And in this case I would minus 2 from both sides, and I get a is equal to x minus 2. So now I have a rearranged formula generated from the original formula that allows me to quickly solve for a. Okay, the next part, we still want to rearrange that so that it's a is isolated. In this case, I've got that 5 that's in the denominator position. So I'm going to multiply both sides by 5. The 5's cancel. I get a 5x equals a. And remember, that's the same thing as a is equal to 5x. Again, a little bit more conventional to write it with the unknown variable that you're trying to solve in the left-hand position. Okay, number 3, in this case, I've got the a on the bottom. So if I multiply both sides by a to get rid of that denominator, the a's cancel on this side, and I'm left with a times n equals 12. Well, again, I don't want that n there because I want it to read out as a equals something. So this is a times n, so we will divide by n on both sides, and it cancels, and I'm left with a equals 12 divided by n. Okay, now we're going to move to something a little bit more complex. I still have 2 variables, but I've now got a couple coefficients, or sorry, a couple constants there. But what do I do first here? Just like we do with any algebra, I'm trying to solve for a. However, a is in the denominator position right now, so I'm going to multiply both sides by a. It cancels the a's right there and gets rid of that denominator. I'm left with q plus 4 equals 5 times a. Now, in this case, what do I want to do? I want the a to be isolated, so I need to get rid of that 5 by dividing on both sides, and I end up with a final rearranged formula of a equals q plus 4 divided by 5. All right, easy peasy. Let's move on to the last one, question number 5. In this case, I have 3 variables, but it really doesn't matter. Again, all I'm trying to do is just isolate that a. So I want the a on the left side, and the 2, the t, and the negative 3, and that z over on the other side. We just need to follow the steps in the correct order so that they're arranged properly, and when we substitute values in there, we get the correct answers. So in this case, if I've got 2 t's right here, I'm going to get rid of those 2 t's by taking them away. I'm going to subtract them. Whatever I do to one side, I need to do to the other side. They cancel on the left. Now I've got a negative 3a is equal to z minus 2t. And I don't want that negative 3 to be attached to that a, so I'm going to divide by negative 3 on both sides, and the line needs to extend under both the z and the negative 2t. So we've got that binomial up top right there, and the line needs to go underneath both of those, and the negative 3 on the bottom. It cancels on the left side, so if we're going to rewrite this nicely, it's going to be a is equal to z minus 2 times t divided by negative 3. Okay, this is done, and as usual, student work is on the right. Get it done while you pause the video and come back to check your answers. Okay, so in this case, you are going to be solving for the unknown variable x, x and rearranging it, not solving in this case, but rearranging rather. And we should get x equals negative y plus 4. And this one's a little bit complex, because what you end up with right here is this negative x equals y minus 4. Now we haven't seen this to this point where there's two items on the other side. I've got a variable and a number. So usually we have negative x equals negative 4, and we just say therefore x equals positive 4 by changing the sign. Now if I change the sign of the x and make it positive, I need to change the signs of both of those. The y that was positive becomes negative, and the 4 that was negative becomes positive. Okay, and question number 2, we should get x equals 6y. For question number 3, it's going to be x equals negative 4 divided by y. Question number 4 is going to be x equals 24 minus y. And the last one, to end the lesson, we get y equals, what did I do wrong? Obviously, I don't want to do that. Okay, we're going to redo this one together, because we're not trying to isolate y, we're trying to isolate x. So I'm going to go right back here and do it with you. So I'll erase all that. The first step is correct. I'm going to multiply both sides by y, and that's going to cancel these y's, and I have 3x plus 6 is equal to 3y. So in this case, I want to isolate the x, not the y. So last time I divided by 3 to isolate the y. What I need to do is subtract the 6 from both sides, and I get 3x equals 3y minus 6. Then I want to divide both sides by 3, leaving us with the value of x is determined by 3y minus 6, all divided by 3. Okay, lucky I caught that. And there we go, the lesson is done. We'll see you in class, and we will get the textbook questions all finished up.